First of all, hello to everyone, and again, welcome to our very first Continuum Town Hall meeting. We're really excited to be here with all of you, and would first like to start by thanking all of you for taking some time out of your day to meet with us to hear about some new developments in the latest release of Continuum, as well as some upcoming developments that we're working on. And we're also here to hear your thoughts and to get your feedback on the software, areas where it might be improved, areas where you've met some challenges. So we're really looking forward to that part of the town hall, which is the open forum. So as mentioned, yeah, we have folks here from South Africa who's talking to Sarian. And really, we have folks here from all over the world. And it is just so great to see. And so really a special thank you to those people who stayed up late tonight to join us. I know we have some folks from Vietnam, so I know it is pretty late there. So a special thank you to you guys. Because at One Energy, it really has been our goal here for a while to build out this global community of Continuum users who get together to collaborate and help to advance this tool. So this is a pretty exciting moment to be here with all of you. So with that, let's go ahead and get started. We have a few slides prepared and a couple of quick demos to show you with a few or a couple of the new features in the latest release. And then after we go through those slides and talk about how to become a Continuum contributor, then we'll open it up to the open forum. We're hoping the last 20 minutes or so will be open to discussion, questions, anything that you all want to talk about. So first, some introductions. I'm Liz Walls. I'm the lead developer and creator of the Continuum Wind Energy software. I have been working as a wind energy engineer / software developer in the wind industry since 2007. I have extensive experience in pre-construction wind resource assessment, as well as in operational wind farm analysis. And I started building this tool, Continuum, about 10 years ago. And back then, it was really primarily focused on wind flow modeling. But the software really took off in terms of development and expanded capabilities in 2016, when my company was acquired by One Energy Enterprises, along with the Continuum software. And since then, we have built out several new additional modules that are all needed to conduct the full pre-construction wind resource assessment. And we also spent a good amount of time generating unit tests for all the critical functions in the software and documenting the algorithms and code. But probably the most exciting thing that happened after One Energy acquired Continuum was working towards publishing the code as an open source software and releasing it to the community. You might be wondering, why One Energy would want to make this tool freely available to the public. And the reason for that is that we really see the value in community collaboration, and we truly believe that the way to advance the industry is to make the tools free and open source. So while we won't generate any revenue on software licenses, we will see the benefit of more advanced algorithms and better methods, which will help us in our pre-construction efforts and help the wind industry as a whole. So as I mentioned, I joined One Energy back in 2016, and this is when I had the pleasure of meeting Erin Reckley, who is a very talented meteorologist and who has been instrumental in shaping and guiding the development of the software. And she's helped in this capacity for several years now, but we just recently made it official with the title of product manager. So with that, Erin, would you like to introduce yourself a little further?
Yeah, thanks, Liz. I'm Erin Reckley, and as Liz said, I've been working with Continuum for a while. I started at One Energy in 2015, doing some R&D work, and also in the pre-construction wind energy estimates. And now I'm in their analytics group doing energy management and also getting to play with the Continuum software package. So I do a lot with the determining new methods and algorithms specifically for Continuum, and then also the end user experience, trying to make that as impactful as possible. My background, I do have an engineering degree, but then also an atmospheric science degree, so I get a little bit of both. I primarily have been working with numerical weather prediction in the wind industry. So I've been in the wind industry for 10, 12 years or so, either directly wind resource pre-construction assessments or tangentially related, doing some wind forecasting for large ITO or ISOs and RTOs. And I'm really, really excited to be a part of Continuum and this first town hall, especially chatting with you all, seeing if you've used it before, pros, cons, things you like, things you don't like. and see how we can make this better. And so, yeah, I'm very excited about this kind of global community that we're trying to create to better move the industry forward in general. So kind of with our introductions, that's a little bit about us. Liz is going to kind of talk through some of these new key features in the newest release that we just released probably 2-ish weeks ago, which is 1.2.9.
Okay, so we're jumping into a couple of new features in the latest release. So we had a user who was trying to do some wind flow modeling at an offshore site, and they had their own land cover key. For those unfamiliar, land cover key is what converts land cover codes to surface roughness and displacement height, which is then used in the wind flow model. And so for water, really low surface roughness, right? And so this user was using a value of 0 as a surface roughness. However, that was getting ignored, right? We can't have 0 as a value in the surface roughness. So we'll show you here the equation, the sort of base equation of the continuum wind flow model is shown right here, right? So there are 4 components to the wind flow model. So changes in the upwind and downwind exposure affect the wind speed at a site, as well as the upwind and downwind surface roughness. And so the equation we have expanded out here is taking a closer look at the surface roughness portion of the wind flow model. And you'll see there's a denominator, Z naught, and that Z naught is a surface roughness. And so obviously we can't have a division by 0. So that's why that part is in the code that ignores a surface roughness of 0. But unfortunately, what that was doing was that was ignoring the smooth surface of the water and wasn't generating the wind speed estimates as expected. So now in the new version, a little note will pop up saying, oh, you can't have a surface roughness of 0, enter in some other non-zero value. So for example, in the NLCD, which is the National Land Cover Database for the United States, the default surface roughness for water is 0.002. So just want to make sure people are aware of that, that is why that note will now pop up, and to make sure that your water land cover zones have a surface roughness something other than 0. All right, the next one. This is a really handy new feature in the round robin module. So the round robin module is a really handy tool that you can use when conducting wind flow modeling. In the round robin, or some people call it the leave one out analysis, what it does is it systematically omits Met towers from the wind flow model creation, creates a wind flow model with a subset of Met towers, and then predicts the wind speed at all of the towers that were omitted from that model. And it does it with every possible combination of Met towers for every subset size. So before, what you had to do is you had to select each subset size from a Met tower subset size of 1 to n-1, n being the total number of Met towers. You had to do that. You had to click the button every single time for every subset size. Now there's a button that says just do all of them. So that's pretty handy. Click the button, do all round robins, and it will do, like I said, wind flow model creation using every single combination of Met towers, and then using those to predict the omitted Met towers, which gives you a good indication of the uncertainty of your wind flow model. Okay, moving on. I think this will bring us to our first quick demo. Yes, so we had a user who was doing some wind flow modeling at a site with a single Met tower. And so if you have a single Met tower, there's no way for the software to generate those site calibrated coefficients using the machine learning algorithm, which looks at Met cross prediction errors and tries to minimize. If you only have one Met tower, obviously you can't do a Met cross prediction. So in Continuum, it uses the default model coefficients. But this user wanted to adjust those coefficients as he saw fit to fine tune his wind flow model. And so there has always been this feature in Continuum where you can export model coefficients to a CSV, and then you can make changes to it, modify the coefficients to some user-defined value, and then import it back in into the software. It was a little buggy in the latest, or in a couple of versions ago, so I worked on that to smooth that out. So I'm just going to quickly give a quick demo on how that works. for those of you who are interested in importing your own user-defined model coefficients. So I'm going to go ahead and share my screen. Okay, so I have a instance of Continuum loaded up here, and here I have a single Met tower. And I have several turbines loaded in, and I've already created the model. And again, this was used, or the estimates were generated using the default model coefficients that are built into Continuum. So if we go to the gross turbine tab, we can see, yeah, the average wind speed of the turbines was 8.14 meters per second. So if you're looking at your results, maybe you're looking at, the relationship between the down exposure and wind speed or roughness and say, you know what, I think that the roughness is not playing a big enough part. I want to bump up how much of an impact the surface roughness has on the model. What you can do in the situation, you go to the Advanced tab, and there's these two buttons up top here, Import and Export Model Parameters. So first I'm going to do Export, and this is going to be the default model coefficients that will get exported. And so that generates a CSV right here. I'm going to open it up. And so the exact same format is used to then import coefficients back into the model. Okay, so there is the CSV. And so like I said, for this demo, I'm saying, I think I want to increase how much the surface roughness is affecting the wind speed estimate. So to do that, I'm going to change these three stability parameters, which are the tunable parameters in the surface roughness model. So I'm going to change that from 1 to 2. And then I'll save this as some other name. We'll call this the modified coefficients. And then we go back to Continuum and say, okay, I want to bring in those parameters that I just defined, modified coefficients. And we're just going to read those in. And then I'm going to have to go back and, now it's saying this is an imported model that we're using. It's no longer the default coefficients. So I'm going to generate my estimates again. Okay, so remember that the average wind speed for the turbines was 8.14, now is a lower wind speed. All right, so it is using those new coefficients. And then we can see now that there's more of a trend down as the roughness increases. Now the surface roughness is playing a larger role in the windfall model. So that's how that's done. So that's how you, again, export, import user-defined model coefficients, if that is something that you need to do. Mainly, it would be used in a situation where you only have 1 or 2 towers and you have a pretty good idea of what should be the big driver of the windfall model. And again, the ability just to change those coefficients and seeing the impact on the estimated values. All right, so that is the first demo, and we're going to go back now to the slides.
It'll get there.
No worries. Okay, so now the second demo has to do with this really handy new tool to automatically download topography data. So this is a new tool that's available in the top menu bar called Tools in Continuum. And so this uses another open source software called it's called Open Topography or OpenTopo. They have an API that you can use for free after registering. So you register through OpenTopo, you get an API key, and then you're able to access several different sources of elevation data for your model. And so for those who are unfamiliar, up until now, what you had to do in Continuum is you had to download topography data somewhere else using a variety of sources, and then format it in QGIS and get the GeoTIFF, making sure the GeoTIFF covered the right area, and then you'd bring it into Continuum. So it did require a few steps. And so this brings it all within the software and just makes it a much smoother and more streamlined process. So just a quick demo on how that one works. Okay, so I have Continuum, just a blank instance of Continuum, and I have an array of turbines loaded in. So turbine layout has been imported. And so if I say, okay, this is my turbine layout, I want to go get some topography data that will cover this area. So what you do is you go up to Tools, and you click Download Topography Data, and that opens up this dialog. So a few things here. So first, yeah, we'll give it a name. So you can give the file name that you download whatever name makes sense for your project, etc. As I mentioned, you do need an Open Topography API key. It's really easy to get. You just log on to portal.opentopography.org, which is listed up here to help you out. You log in and you get your API key after signing up and agreeing to some terms and conditions. So I'm going to copy my key, enter it up here. And then a very cool thing that they allow or that they have in OpenTopo is a lot of different sources of topography data. So you can choose from this list of available sources. And if you click on one, it gives a little description of what it is. It tells you what the resolution is in meters, as well as a link onto the OpenTopography website with more details of what that data source is. So we have the NASA DEM, which is a modernization of the SRTM dataset. Then we also have those SRTM, which is Shuttle Radar Topography Mission. So there's SRTM 30, there's SRTM 90 resolution, so a few different sources. So you select the data set that you want, and then you can enter in the area of topography data that you want to download. And this is probably the most useful feature of this tool, is you click this button, Find Bounding Box around the METs and turbines, using this defined buffer. So for those of you who don't know, when you're building a wind flow model, Continuum needs a buffer of at least 12 kilometers around every MET tower and around every turbine site. Just to be on the sure side, I typically will use 15 kilometers, which is why that is the default here. And so these coordinates have looked at the array of turbines. I don't have any MET towers in this instance right now, but it would include those locations as well. And then it defines this bounding box to make sure that there's that buffer around each location. So we're going to go with that. Those are the coordinates, and then you just click Submit. And then I'm going to save it in the Topo Data Download folder. And it usually takes just a couple seconds, and then there should be a button that pops up saying that it worked. So file downloaded and saved. And then that file is now ready to go. So there's our GeoTIFF. And then to install it, you just click Import Elevation Data. And then it will read it in. So yeah, much more streamlined and an easier way to get your topography data. Again, that's the biggest part, is ensuring that it covers the area that you need. I know it's a pain in the butt to get your data loaded in and like, oh shoot, I need to go a little bit further north in order to cover all the MET tower area. So this ensures that you don't run into that problem, and it's all just automated. Okay, so that is that demo. I'll turn it back to Erin.
Yep, so those are just the key things that have kind of changed in this most recent release. We do have some things that are on the docket that we're currently working on. I gotta go to the next slide. That we're super pumped about, and we just kind of want to give a little teaser of things to be looking forward to with some new releases coming out. So the first one that we want to kind of talk about is an update to the round robin calculations to have all of those running in parallel. So when Liz was talking about how we added the button where you can do all of them, you're doing a lot of calculations with all of that. So being able to run just specifically the round robin stuff in parallel really speeds up that computational time. So we've been running a lot of different iterations of some round robin calculations with a whole bunch of different METs. So the more METs you have, the more iterations that you're going to have, the more ways that you can combine all of the different METs, and so you start having a lot of computation time. So adding these in with being able to use parallel processing really does speed up that process. So that's been in the works, and we're kind of testing that out right now. So it should help speed that up in terms of computation time. The second big thing is including a land cover downloader tool. So just like that topography downloader tool that Liz was just demonstrating, we want to do the same thing with land cover. So there is a land cover API out there. We just kind of have to get all the kinks worked out and make sure that it can play nicely within Continuum, so that we're going to be able to access and download the land cover data internally within the software itself. So you're not going to have to, again, go externally to a different website, download it, snip it out, make sure you've got all the right bounds, that it's similar to your topography data. So again, it's just kind of making things a little bit more streamlined and easier for the end user. And then finally, the thing that I'm the most pumped about, we are adding in an elevation and valley model component into the actual wind flow model itself. So the current model, it really is only looking at exposure and surface roughness when it's determining its model coefficients. But this new component, we're going to start adding in elevation differences. So it's going to be really, really helpful in areas that we have large differences in elevation across complex sites. So we're in the middle of a whole bunch of different testing with this, making sure, is this the right algorithm? Is it doing what we expect it to be doing? But as we've been seeing so far, it's looking really promising. It has been decreasing the RMS of the MET cross prediction errors. As you can kind of see from that graph, the blue bars, those are without the elevation component, and then the orange is with the elevation component. So we are decreasing those errors, which in any type of model, that's what you want to do, right? You want to decrease and make your model that much better. So it's definitely looking really, really promising. But we've got a little bit more work to do, just in terms of making sure across all different types of sites, across all different types of number of METs that we're including, and all of that it's doing what we're thinking, just kind of across the board. But yeah, like I say, it's super encouraging. That's what I'm really excited about as a big new release.
Okay, I'm equally as excited about that. We definitely had some celebration emojis sent back and forth when we saw some of those results. So definitely excited to do further testing and to release that in a future release. So now we're going to shift gears a little bit, and we are going to recognize two Continuum contributors. So it's very exciting that we're now at a position where the community is starting to contribute to the software. And as much as we absolutely value people's input, and we appreciate so much people's time and effort and ideas going into this. And so because of that, we want to make sure to spend just a couple minutes to recognize those people who have made contributions to the software. So the very first one, who I believe is on the chat, is Shehan Gones. I don't know if you can wave or say hi in this chat, but he was our very first Continuum contributor. And so what he did was he created a tutorial on how to download land cover data for a site outside the US. So at the time, the only tutorial for land cover data on the Continuum website was focused on the US. So it was a tutorial on how to download data from the US National Land Cover Database. Shehan emailed me saying, what do we do for global sites? And I said, that's a good question. I'm not sure. And so he took the initiative to go out there and find a solution. And he was able to find some tools to use to access and format land cover data from several different global sources: Corinne, the Global Wind Atlas, and World Cover. And so he very graciously took the time to create a tutorial, a really wonderful step-by-step and thorough explanation of how to access that data, and that is now available on our website. So thank you very much, Shehan, for that contribution. Our second one is Neha, and she was she was a summer intern at One Energy. So she worked with Aaron and I and a few other folks at the company. She has a background in software. She was pretty excited to pick up a project Continuum related, but that would leverage her software development skills. So she is the one who was behind that topography auto downloader that we went over just a few minutes ago. That was one of her projects over the summer. So she did a great job with that in researching how to use the API, developing the GUI, testing it, and then working with me to implement it into version 1.2.9. So thank you very much to Neha for bringing an auto downloader, a tool that has been, that I've wanted to see for a long time. So really grateful to your work as well. And with that, you might be wondering how to become a contributor. What does that mean? And so I think Aaron is going to give, oh no, am I taking this one?
Yeah.
Yeah, I'll get, all right, so I'll start off. So a little bit of discussion of what does that mean, Continuum contributor? Well, in essence, very simple. A Continuum contributor is someone who is actively participating in the enhancement of the Continuum wind energy software. And really, our mission, to put it very simply, is, as I've said before, we want to further the wind industry. And what better way but by collaborating with professionals in the industry as well as researchers and students. So it's our mission to through Continuum and this community to further the industry in terms of the advancement of methodologies and accuracy of our estimates. So to help in that effort, instead of kind of having an open-ended, hey, just contribute to the software, Aaron and I spent quite a bit of time creating an extensive list of areas where we think we could use some help. Areas of open research projects, areas where the software could use some better coding. And so we've compiled this list on the Continuum website. It's a new page, actually just got published this morning. So it's continuumwind.com/contributors. So it has that long list again of the open projects that you can take a look through and see what might be interesting for you. And then there's a contact form on that same page where you can do a few things. You can apply to be a contributor, but you can also just submit feedback or suggestions on things that maybe we should be looking at or areas where the software might be improved. And on top of that, you can also submit ideas for different research projects. Part of our motivation for this was, both Aaron and I went through grad school, and, coming up with a project for your master's or even PhD thesis can be a little daunting, right? You want something that is worthwhile and something that you can really sink your teeth into. And so a lot of the projects on this list could turn into a master's or PhD project. And so we're excited to sort of help get students on their way with some good, useful, and interesting R&D projects. And so in that contact form, if you have an additional idea for R&D that might be suitable for a student or even a postdoc, whatever, you can submit those ideas, and we welcome and encourage you to do that so that we can, keep growing this list and have lots of different areas, people of different abilities and different levels could potentially contribute. And then a few more details. So to further help you kind of sort through this list, all the projects are broken into two different categories, either software development or coding or R&D. So if it's labeled as coding or software development, expect to be getting into the code, expect to be doing some programming and making some changes to the current framework of the software. For R&D projects, we want to make sure that there are projects out there for folks who are not programmers, so people who just want to explore different parts of the model, of the software, I should say, whether it's a wind flow model, a wake loss model, site suitability modeling, all sorts of different areas are open and ready for research to be conducted. So we also have a lot of projects that are strictly R&D based. But then again, some of them are both. So if you want a little bit of this, want to get some experience in some software programming, but you're also trying to do some research for school or what have you, there are several projects that would dive into both coding and R&D. Okay. Now, next steps, more specifics on the process. I'll turn it over to you, Aaron.
Yeah, so I want to kind of reiterate what Liz was saying, like that list that we do have, that's just kind of what we've come up with, the things that we want to tackle eventually. It's non-exhaustive. So if you have any ideas of things that you want to see in the software or you want to improve, let us know. Like, we want this to be a very community oriented, very collaborative piece of software. So please kind of talk, give as much information and feedback as you can. So if being a Continuum contributor sounds like something you'd be interested in, we've kind of made a couple key steps just to make sure that everyone's on the same page, and people aren't repeating other projects and things of that sort. So we've got a little process in place for how you can become a Continuum contributor. The first one, just see which project in general you would have an interest in, that you'd want to take lead on and that you'd want to take ownership. You can either, again, choose from that kind of long running list that we've got of things, or propose your whole new one that you'd be interested in seeing come to fruition. Once you've kind of figured out what project, what avenue you want to go a little deeper in on, then schedule a little quick call with Liz and I. It'll be super quick, just 15 minutes maximum. It's just mainly to get everyone on the same page and make sure, hey, this is the route that I want to go down. Are we all in agreement of this is something that would be super beneficial or an avenue even worth pursuing? So just kind of give us a heads up of, hey, I'm going to be working on this type of thing. And how you kind of schedule that is filling out that form on the contributors page on the Continuum website that Liz was just talking about. If it is a software development project, in terms of you'll be doing coding, we do ask that you have a GitHub account and that you are familiar with the Git concept of branching and all of that, and understanding pulling and push requests. And then also, because Continuum is in C#, probably would be beneficial if you knew C#. It is an object-oriented programming language, so it's pretty similar to a lot of other languages, like in terms of syntax. It's just little nuances here and there. So just kind of get a little bit more familiar with C#. While you're kind of doing all of this work behind the scenes and working on whatever project you are, we do ask that you try to attend these town halls and highlight any progress that you've made. We want to be your cheerleaders and have the whole community, pushing you on and saying, good job, this is awesome, or hey, have you thought about doing it this way or thinking about this type of avenue? So try to attend these town halls and give a little bit of progress feedback on what you've been doing. We'd also ask if you can kind of just shoot Liz and I an email saying, hey, I've gotten this part done within the past month. So monthly emails. And if you've been swamped at work or swamped at school, just, again, give us a heads up. Hey, it's been super busy. I haven't been able to touch in my project, but I'm thinking about X, Y, and Z. So again, it's kind of just a communication, letting everyone kind of in the big picture know what's going on, where things are progressing. And then I harp on a lot is documentation. Documentation is near and dear to my heart. So if you've come up with a really cool algorithm and you've tested it out and things are looking great and you want to implement it, we need some sort of proof. I mean, I trust you guys, but having the proof and the numbers just kind of makes it that much more strong to be able to say, all right, we're putting it in, it's go time. So if you are doing some sort of software development, make sure you're documenting inside the code itself. The code already is very well documented. So just kind of keeping up with that trend to make sure that people can kind of follow your breadcrumbs as you're going along. Then also writing white papers if it's any new type of algorithm or new type of method, just kind of proving, again, this is better than what we're currently doing. And then finally, putting together some user tutorials. Being an end user, sometimes you're like, how am I supposed to do this again? How do I do that again? Having those user tutorials for some other person who wants to figure out how to run Continuum in an efficient way is super beneficial. So having those written up as you kind of create these new pieces of the software is super, super helpful. And then once kind of you get through all that and things are looking great, it'll be peer reviewed and go through a whole bunch of unit testing on our end. And once it all passes all of that, then we send out a little note. Hey, new release coming out with this contributor or this Continuum contributor and this specific part of the project. Make sure you check it out. So we're really excited again to have all of you guys, if you're interested, to become contributors and make your little impact on the software and then on the industry as a whole, if you think about it in that way. And again, that is our website that you can go to. There's a contributors tab now that has the list of open projects and that form to kind of get in touch with Liz and I.
Okay, well, we left exactly 22 minutes. I think that's pretty good. Pretty much what we were aiming for. So great. So yeah, so now it's time to shift gears a little bit to the open forum part of this session. So we don't have any, sort of strict format in place. So, but there is the chat that you can, enter your question in on the chat. Or suppose you can also raise your hand if you want to just ask your question verbally. That is also totally fine. So yeah, we'll give just a couple of minutes for people to enter some questions and we'll take them one by one. Or the software is working just perfectly and there are no questions or concerns. No, I'm kidding. There are areas that could be improved, no doubt about it. So yeah. Well, we can get the ball rolling with some things to discuss. Let's see here. Is anyone from One Energy on the line? Darshan, I think you had a question, didn't you, that you were posing to me earlier today? Did you want to kick off the discussion?
Yes, I can. I can do that.
Great, thank you.
Well, first off, thank you for this presentation. I think it's pretty informative, especially in terms of the new features coming down the line. But yeah, the question I had was about the data sets that you can put into C3. So I know it gives you the option to load in time series or tab files. The sites that I am working with generally have like a mixture of MET datasets and LiDAR datasets. Is C3 able to work with like a mixture of different MET and LiDAR datasets in it? Or do you have to restrict it to just MET-based runs versus LiDAR-based runs?
Oh, good question. You can have a mixture of any type of data sets. The only thing you can't do is you can't mix tab files with time series. So you have to have one or the other. So tab files contain just the wind speed, wind direction distribution. So really small, easy to work with files, which are really nice, especially if you have a bunch of Met towers you're working with. Obviously, time series data files have a lot more information on the temporal basis, directional, all sorts of additional information that's really helpful. So you can't do tab files and time series in the same file. You have to do one or the other. But if you're using time series, then you can use Met towers as well as LiDARs in the same project. Yeah, so that is no problem. You can also have data sets with different time intervals. So I was working with some mesoscale output from NREL, and the data was on a 15-minute basis. But then I also had data that was on a 10-minute basis. And so that I had to work out a couple little bugs in Continuum, but you can do that now. So as long as they're both time series based, they can be different time intervals, which is pretty handy. So does that answer your question then?
Yes, yes, it does.
Great. Okay. Let's see here. Any other questions? I'm curious how many people were familiar with the round robin feature of the tool. Maybe we'll just do like a quick raise of hands. Who online, who in the meeting right now has used the round robin tool in Continuum before? Okay. Okay, so it looks like we have some people online, or maybe on here to learn more about the software, but maybe haven't used it all that much. But I highly recommend the round robin tool. Erin and I use it all the time for client work. It really is just such a useful insight in terms of understanding the uncertainty of your wind flow model, and also recognizing or identifying outliers in your Met data sets, because we assume a lot of time when we do wind flow modeling that our Met data is perfect, right? That there's nothing wrong with the data, that the wind vanes were installed correctly, etc. But sometimes the Met data is not good for a variety of reasons, and so the round robin analysis really helps to highlight outliers that you could then take a closer look at and say, oh, there's something up with this wind direction data. This looks totally wrong, and that's why it's throwing off the wind flow model. So if you haven't explored the round robin, I again highly recommend it. You do all the generation of the data in Continuum, but then you can export all of the results, so you can really generate some really interesting data to take a look at.
Hey Liz, so I have
Yes.
another question.
Sure.
So I was looking through the software, and I believe on the site conditions tab, there's a section for terrain complexity.
Mm-hmm.
And it gives you the option to calculate the terrain complexity for your site, for your wind farm based on the IEC method. But then it also gives you the option to calculate using something called a P10 exposure method. Could you just briefly explain what that method is and how it works?
Absolutely. We're actually working on a paper that we hopefully will have out in public domain in the next 6 months or so that talks about all this stuff. So first of all, the P10 exposure is a concept that I came up with a number of years ago when I was developing the Continuum wind flow model. And basically it's a measure of terrain complexity looking at the exposure across a site. So the P10, that refers to the exceedance level, where P10 refers to a level where that value exceeds or is in the top 10 percentile of the distribution. And so the way that the P10 exposure works is, for a given site, it will look at the area directly surrounding it, calculate the exposure at several different gridded locations around your site, and look at the distribution of the exposure at your site and around it, and then comes up with the P10 exposure. The idea being that the complexity of your site is as complex as the most complex area directly surrounding where your Met tower is. And I found that the P10 exposure is just a good way to quantifiably, or to quantify the level of terrain complexity. This has been something that we as an industry have sort of struggled with or wrestled with over the last decade, if not longer, is how to like what is complex. People sort of throw that term around without any sort of true definition. People say it's highly complex, but it's pretty subjective. So in the IEC, there's an algorithm where they try to capture complexity, but what they use, or what they recommend, is looking at the average slope of the site directionally, and also looking at how much the terrain deviates from a smooth surface, from a smooth plane. And so, but what we found, so again, we're working on this paper that I'm excited to publish, but what we found is that if you use the IEC algorithm, it often doesn't really capture the true level of complexity at a site, because just looking at the average slope doesn't really capture variability the way that exposure does. You can think about a site, that has, huge, big dips in it. but with no slope at all, but there's still, incredible variability in the terrain, then that would get a slope of 0. That'd be considered not complex when looking at the slope. So essentially, we found that it's not the best way to clearly understand and quantify the level of terrain complexity, whereas the P10 exposure, in my opinion, is more straightforward and is easier to interpret the results. But in Continuum, we want to make sure that users had the ability to look at both measures of terrain complexity, both using the IEC recommended methodology as well as the P10 exposure, which is what, again, is used in the Continuum wind flow model to quantify terrain complexity. And through this study that we'll be publishing, we looked at 12 different project areas across the US and quantified the terrain complexity. We feel that it's just a better method to quantify the complexity. So stay tuned for more on that, but yeah, good question. Thanks, Darshan. Jessica.
Hi, Liz. Thanks so much for the forum. It's fantastic. I had a question about wake loss with multiple different turbine models. A lot of what, as we're siting wind farms, we also, we oftentimes have to deal with upwind or downwind other, turbine models from other projects. And I'm wondering if Continuum 3 currently has the ability to, or if you have, thought about incorporating the ability to have different turbine models specifically when calculating wake losses.
Really good question. Thank you. And yeah, I've had this question posed by other users. I think someone might be online now who asked that same question. And it's definitely an important thing to think about, especially as more and more wind farms are getting built and we have more external wind farms, waking each other. Often they're going to have different models and they'll have different hub heights and different rotor diameters. So this is an important thing to capture. And so to answer your question, currently, no, Continuum assumes that all turbines in the layout have the same, are the same model, that they're have the same hub height, same rotor diameter, same power curve. So this is an area where we want to expand the software. It shouldn't be too terribly difficult to code out. It's just a matter of taking the wind flow model to different heights, right? Because right now the wind flow model that is generated is at a single hub height. And so what we would do is we would generate an additional wind flow model at a different height and have the two talk to each other. So definitely an area that we've thought about, but currently the software, does not do it yet. But it's definitely on our radar, definitely an area that we want to work on in the hopefully near future.
Thanks so much.
Thank you for the question. Also want to say thank you for all of you who registered in filling out the 3 questions, the poll questions that we asked to fill out. I have to say I was very encouraged to hear that there are a number of folks in this community who are not just interested, but very interested in becoming a Continuum contributor. So again, Erin and I are just really looking forward to working with you and collaborating and talking about how to make this software better. And in this forum too, if there's something that's not working or something that, you've struggled with, don't be shy. We can take constructive criticism. That's why we're here. And that's how the software improves, right? So every note that we get through the website with questions, or, if you run into an error, we appreciate all that feedback so much. So really, like I said, don't be shy. We encourage and welcome all sorts of feedback, positive and negative.
And to add on to that, we also like brainstorming. So if you have an idea of, hey, something, we want to add something, but I don't know how to do it, we'd love to, chat about it and kind of do some brainstorming, see what sticks, what doesn't stick, what makes sense. Sometimes having other people to talk issues through helps tremendously. So we want to be open and available to be able to do that as well.
Oh, we have a question here about how often we'll have these town halls. That's a good question, Parv. I don't think we really have a set timeline. Might be a good question for the community. You know, how often would this be helpful? Initially, I think we were thinking, every few months. Do you remember, Erin? What were we
I
talking
think we
about?
were talking about once a quarter.
Once a quarter. Yeah. I think that would be good. Yeah. Every 3 months or so. So yeah, we'll stick with that, and if it turns out that there's just too much to cover, if we don't have one every month, maybe we'll change it to more frequently than that. But I think for starters, yeah, we'll go with once a quarter. So I guess this is our fall meeting, and so we'll have a winter meeting in a few months here. Oh, we have a hand up from Bauer. Go ahead, Bauer.
Yes. I wanted to say I was really excited for the topography import and the land cover import. I think that's a super helpful tool. I did have a clarifying question about it though. When we're downloading both of those, I know sometimes we have to worry about projections. So kind of a two-parter. When we import, can we change projections when we input them in? And then follow up, do we have to worry about projecting both of them, or will Continuum take care of that?
Yeah, you don't need to worry about projections at all in this. So you specify the latitude and longitude as opposed to the UTM. So the projection only really comes into play when you're dealing with UTM coordinates that are, Cartesian, that have been splayed out onto a flat surface that is not flat. But when dealing with latitude and longitude, you don't need to worry about that necessarily. And so when you do the download, you don't worry about the projection. And then when you import it, the only thing you have to tell Continuum is what UTM zone you're in, because then it will then convert the lat longs into UTM within that zone. But really you can pick any UTM zone. It will just skew the stuff in different ways to fit it to that zone. So it should be pretty streamlined. And yeah, again, you just have to know your zone. That is another thing I wanted to mention. A few users have, provided videos, which have been really helpful when they've been running into issues. And one thing I've noticed is when people are entering their topography data and they enter in the UTM zone, people are going down that really long drop-down list to find their zone. You can actually just type your zone in. You can just type in the number into the drop-down as opposed to finding the number in that big long drop-down list. So that's just a quick little, tip on how to make that a little easier.
Awesome. Thank you.
Thank you for the question. Claire, please go ahead.
Hi. This might be a silly question, but I was wondering if there was any documentation on a sensitivity analysis for Continuum and the different modules.
If there's any documentation for, didn't hear the last part.
For sensitivity analysis for Continuum and the different models within it.
Sensitivity on like the wind flow model?
Yeah, or like the, like I guess I was looking for like the site conditions modeling and any, like I guess individual tabs within Continuum.
There definitely could be more for sensitivities. There is one project on the list of open projects that is exploring the wake loss model and how the different parameters in the wake loss model impact results. So there's a lot of open research that we could define all around sensitivities. On top of that, we're looking at the ice throw model and how there are a lot of assumptions in the ice throw model in terms of the shape of the ice and how that affects the lift and drag. So a lot of opportunity to do sensitivity analysis there. So to answer your question, I'd say that there's a lot more work to be done on that side of things. And yeah, I think there is area for more. There's still so much to research. So, but yeah, if you are looking for documentation, we do put pretty much everything that we do onto the website under publications. So as more stuff like this is generated, we'll make sure to post all that on the website.
All right, thank you.
Thank you. Okay, so we have a question from Vin in the Q&A. Vin, you were the fellow who was working with the single Met Tower with the offshore site, right? Where you're trying to modify your coefficients?
Yes, yeah, please.
Yes. Thank you for joining us. Can you remind me where you're joining us from?
I'm from Vietnam.
From Vietnam. It must be late
Yes.
there. Thank you so much for staying up late to join us today.
Yes, yes, no worry.
Okay, so you're asking about guidelines for changing model coefficients. I have plans for creating those guidelines. So I'm actually working on a video that dives into the wind flow model theory. And with that, it really explains how the model coefficients are defined. And that should really help with what you're talking about here, about how to adjust those model coefficients and what they'll actually do. So at the moment, I don't have any real documentation or guidelines to share with you other than, just through chat and email, but definitely plan on it to create that video and additional documentation, again, explaining the wind flow model theory, understanding the coefficients so that users can make those modifications. So that is in the works. But if you have questions specifically about your site, feel free to send me results and I can help, guide those changes.
Yes, that would be right. Thank you.
Okay, you're very welcome.
Hi, Liz, Serena here.
Hello.
Hi. Yes, maybe I come from a bit of a different background than most of you. I'm all from a geography and just spatial background, working with meteorologists. So something that I would be interested in is the export of the different maps of site suitability, the noise and that type of
The shadow flicker?
The shadow flicker, that type of thing. We usually, on the environmental side, we use QGIS, or I work in QGIS, and it would be quite nice if one can somehow export some of those maps in a format that you can then import in.
That's a great
your
suggestion.
QGIS projects where
other. Yeah. What format do you think would be most helpful?
It doesn't matter if it's a raster or a vector. It depends on how your model works. What would be easiest for you to work in or to export to?
Raster would definitely be easier. Great.
No,
that's a
fantastic. Fine. We can work with a raster.
Perfect. So yeah, that's a really great suggestion. Probably makes sense. So the shadow flicker, that tool generates maps, looking at the overall over an entire year, what the total number of hours of shadow flicker is, but then you can also look hourly and monthly. So maybe we'll have it set up where users can export any map that whatever map is selected. That's a great suggestion. Thank you, Sarah. That is noted. We'll add that to the list.
Okay, thank you.
You're very welcome. Okay, we have a question from David. No worries about joining a bit late. This is all being recorded, so we'll make sure to post it. Oh, and we're out of time. Hopefully we can answer this real quick. If I get cut off, thank you so much, everyone, for joining us today. Stay tuned for the next town hall, and don't be shy about getting in touch with questions, feedback, or becoming a contributor. So this is software. Thank you. Yeah. This is software in the middle of the WRA software and WRF kind of approach. I think that's probably fair. WRF is wind resource forecasting, so it's a mesoscale model for those of you who are not familiar with it, a numerical weather predictor. And so it is also a community contribution type model. So I think that's fair. Yeah, I think we're probably taking a bit of this and a bit of that. We want this tool to do everything, if not more, than what OpenWind and WindPro and other softwares do. But we also want to embrace the contribution and ideas and guidance from the community. So I think that's a fair statement, David. Okay, with that, I think we'll wrap things up. Thank you so much for your attendance again. Once again, it's been a pleasure and really looking forward to the next time.